Hello, hello. Hey, there we are. And welcome to our weekly videocast live stream. We have a special guest, Natalie Lowe.
Hello.
And we are here to talk about 3D printing. But before we get into 3D printing, we should probably recap some of the week's announcements, I would say. Okay, so first up is the Sound Devices CL-12. We are very excited about the CL-12. It is a fader control surface, a linear fader control surface for the 6 series recorders. We've been eagerly awaiting this. And it's got a phenomenal feature set and phenomenal price point. It works with all of the 6 series recorders. But it works with varying features depending on which model you plug it into. So it gives you 12 faders, it gives you meters, it gives you 3-band EQ, which I'm very, very excited about, but not for all of the recorders. It is a significant development. I think a lot of people have been begging Sound Devices to come up with a replacement for the Cooper mixer, and I think that this is exactly the right choice. This is exactly up their alley, the way they did this. It looks like it's executed perfectly. Can't wait to get our hands on it. On the screen, Natalie, if you can scroll down, there's a handy dandy chart that tells you which features it has. Oh, by the way, it's got 2 different models, a standard model and then what they call, I think they say to pronounce it Alaya, is that right?
It's a surfboard.
So the surfboard model with wood and P&G faders, which I have to say personally I'd go for that one. But the wood comes in 2 flavors, blonde
And redhead.
and redhead.
And they're available for pre-order.
Is that really what they call it?
No, I don't think so. I think they're just referring to it as red mahogany.
Yeah. I think well, I would definitely choose the Alaya.
Here we are, mahogany with red oak stain and curly maple with clear finish.
Which they put blonde in
right.
parentheses on it. I didn't make that up.
No, you did not make that up.
Yeah, so it's exciting. I think so. To compare how it works with the 6 series recorders, if we look on the screen here, so if you have it with a 633, you get obviously only 6 faders. You do not get 3-band EQ. You don't get mix assist monitoring. You get 1 comm, and you get a single return. 664, you get 12 faders, still no 3-band EQ or mix assist monitoring. You do get output level control for left, right, aux1 and aux2, which is cool. Single return and single comm and 3 returns, just same features that 664 has. And then what I'm really excited about is connecting it up to the 688. This really starts to give you a full-blown mixer with 12 faders, 3-band EQ, mix assist monitoring, output level control, track level control for left, right, and aux1 and aux2, and 2 returns and super slot as well. So yeah, I mean it's a pretty compelling product. It's very compelling. We can't wait for them to start shipping. Anybody know? Did they say when they're shipping?
October, the end of October. So you can call and pre-order, or call and ask any questions to Gotham Sound sales, rentals.
That's right.
You can talk directly to Peter Schneider if you'd like.
That's right. Yeah, and so it's gonna be beautiful. It's exactly what we've been waiting for. Other announcements at IBC. It's the new Sennheiser wireless, the EK6042. is finally they have a slot receiver with 2 channels. And interestingly enough, it's compatible with all of the Sennheiser transmitters, everything from the 9000 series all the way down to the Evolution series. So I am excited about this, and of course, this being 2015, it's broadband, so 470 to 654 megahertz. So yeah, it can receive the full UHF spectrum. Yeah, and your full complement of Unislot and Sony, as well as presumably some kind of XLR or TA3 outputs, what they call a piggyback accessory, and then yeah, last but not least, partnered with Sound Devices to make it super slot compatible, which is huge. So you can use it with your 6 series recorders and any other recorder that comes out in the future that's also super slot compatible. So very, very exciting. And then Sony announcing a new wireless system. I know the Sennheiser does look nice. I know the least amount about the new Sony DWX, and they're calling it a network wireless system. Very curious to get our hands on that system. Supposedly it has some kind of 2-way communication. Yeah, very, very interesting. So yeah, so that's that was the week's announcements that I saw. Anything to add? I think that's what we got. So we should move on to 3D.
Okay, so I've been asked to come in and talk about a few things that we've done with our MakerBot. Replicator 2 is what we purchased, and there are tons of 3D printers out there now. There's a lot of options, and all of them, I'm sure, have their own limitations. We have certainly met our match as far as something that can take an idea and mold it to something that you can actually use functionally on a daily basis. So we have U-line bins hanging on the sales floor that I made an adapter to hold them there because we were faced with a problem and we needed something. So it has all those capabilities, and I've had people call in asking for certain ideas, and one customer in particular was using the new Wizicom dual channel receiver, the MCR42, and needed to put it into the Octopack, and was going to, I believe, North Africa, where there was a lot of sand and dust that he was going to experience, and he wanted to cover what was left of the holes inside of the Octopack. So without too much further ado, I am going to jump over to the way that I did this, and there's a couple of different ways you can go about this. But
we should tell people what our goal is for this segment, I think one of the things that I'm excited about this technology that we've talked about a lot is that this can be done by you. If you have an idea, the tools that are out there are free. Granted, the 3D printer is not free, but if you email us a design, we'll print it for you. We only ask that you keep the design open because we really want people to be able to share in this technology. It's incredibly empowering. I'm sorry to go off on a tangent.
No.
But I think since the components and the electronics have gotten so much more sophisticated, there's been a kind of move away from DIY in production sound. And this really injects DIY back into production sound. You're not beholden or dependent on a manufacturer or even a vendor to build or sell you something that you need. You have a problem with some piece of gear, you can build and design it yourself. And so yeah, I mean, I'm super excited because Natalie really, she knows this stuff, and she will take you through sort of step by step how you're able to do this yourself and come up with a design that's printable. So sorry to interrupt.
No, not at all. Yeah, the end goal is that design is at your fingertips, and something like this is a daily necessity and should be something you experiment with, at least. So here is the couple of things I think you'll need is a profile in one of these free programs. I use Tinkercad. There's 123D Design as well that I know people use.
So
And
you just go to tinkercad.com and get an account?
yeah, anything you need is there, and it populates with all sorts of different kind of shape generators and things like that. So bear with me as I open up just some very simple your shape generators. Geometric, there we go. So all this stuff starts with very simple geometric shapes. And again, the idea was to take, and I will show you the article that we did at the time, to take the Octopack that has a small pin in it. If anybody watching wants to find out what that pin is for, and let me know, I'm still curious. To secure the receiver, I'm sure. There's a very good reason. But there was a pin sticking out here, and there are screw holes here that secure the SRB into it. And then we have this, this rogue unit here of WYSICOM that we wanted to make work inside of that. And everybody knew it was possible, but again, there were screw holes that were exposed and concern about dust and dirt and everything like that. So in the end, you can see that the shim that we made creates enough coverage and made it a really nice tight fit, because the multi-pin slat on the inside made a nice hold. And we didn't end up having to use the screws, but if you wanted to use the screws, you can absolutely do that. The good notes here are that you can download the STL file yourself here. And the iterations to success were 6. That's how many times it took to get it right. And what I consider your absolute needs are, which is some kind of 3D printer, the filament to make it work, a digital caliper so that you can get an accurate read on everything, and a CAD program of some sort, and a mouse, because a trackpad won't do when you really want to look at it. So
why is that? Why can't
you
just use
can
it?
right-click and take a look anywhere you want to. Of course, like anything, there are limitations. And actually, this work plane is larger than what the build plate is on the machine itself. So
something to be aware of, that you can easily design something in Tinkercad that's not printable.
yes, absolutely. They're not mutually exclusive, but that is okay. So the idea here is to explain just very quickly, and of course there's a million different places you can learn about this stuff, but very quickly, there are measuring tools. You can make things exact diameters, and this is what we did, is we measured and made sure this is all we needed, which was a 2 millimeter thick little combination of a few different things. So you can see how this was done. This was these individual pieces. This was, I'm just ungrouping it, that hole and that hole. And that is how we ended up with the end job.
Talk more about the holes.
So that is how, well, I mean, that is how you make the shape that you're looking for. So you start with a general idea of it, and then you start to kind of eat it out, where you can change this back to a regular shape. This is how they were all generated. And then made specific to the size of the receiver. So what I did was digital caliper the size of the WYSICOM MCR 42. And just like woodworking, you know, you'll run into things where you shave off 1/4 of an inch when you are actually going to insert something into it or whatever. You have to mess with it. So what I would suggest is, if you're printing something that something has to fit into, I would suggest that you print it, and then, sorry to jump ahead of myself, but ultimately, you know, you're going to have to load this into something and print it. And you'll be able to flip it upside down or flip it right side up or sideways, whatever is the most practical way for it to print. And I would suggest that you print it in a way that you can try it and let it print for about 2 minutes, 3 minutes, and then remove that from the plate and try it on the thing that you're trying to fit it around so that you can see if you're on the right track, because if you're not, there's no reason to print it all the way through. So that's just an inside trick of how you do it. But ultimately, this program is fantastic where you have tools where you can align things in exactitude. And then ultimately you'll make the necessary holes in the units, group everything together by holding shift. This is all, I'm sure, very elementary CAD stuff. And when it's all grouped together, you'll see that you have the unit that you're looking for. You can float this off the plate, you can turn it around and look at it. Whatever you think is necessary. But ultimately, it's going to print, from the bottom up. So if for any reason this was a shape that would work better like this, that would be the way you would print it if it didn't have these flat pieces or if it was significantly wider.
So it seems that the process is define the problem. Seems to be, I need to get this to fit here.
Yes.
And then start to think of it in terms of primitive shapes. So like a rectangle with a rectangular hole in the middle, and then circles around the edges for screw holes or screw plates.
Exactly.
And then literally you group them all together so that what was a bunch of different shapes and holes becomes one solid shape.
Yes.
And then the tricks of printing are important. Like you have to remember, are we able to get a shot of the 3D printer here?
Give us one moment, but yes.
All right. So the 3D printer, we literally ripped this off of the floor. It goes ahead, it goes along, and is this on?
This is not on.
It's not plugged in. All right. Well, anyways, you can see it's got a head here, and it goes across the plate, and so it's got to print. It's got to print in such a way that you start with the bottom layer first. And so when you're designing it, the bottom layer has to make sense in terms of gravity. So like if for some reason we visualized the shape, Natalie, do you mind rotating it sort of 90 degrees? Yeah. Like that wouldn't be a practical way to print it because you have the stuff on the bottom, so it would have to print those first. Then it would have to print that big line across. With no supports on the bottom. And there is a way to turn on supports, but it's much more sort of logical to print it flat first, sort of the biggest surface on the plate first. And that took me a while to figure out.
I think the first thing that totally was a disaster was when I tried to print a reindeer that I found, and it printed its perfect little paws and legs and everything, and then it got up to the body, and it was just a total nightmare.
Yeah.
It was awful. It was a massacre.
There's nothing worse than a deformed reindeer.
There's nothing worse than a deformed reindeer.
It's like a travesty.
So,
and that's it's being said on Jewish New Year, I have to say. So, yeah.
Of the other things that ended up being extremely useful with the 3D printer were the XLR and TA3, TA5 caps that Peter designed. And printing with threads is an absolute art. And it's very difficult to do. And when you get it right, the best thing about 3D printing, just like programming a CNC machine, is it's done forever. You never have to make it again.
There's a thing. So first of all, we got the printer, and we didn't know what we were going to do with it. It wasn't until we had like a really well-defined problem. Like we made shot glasses. And bongs and Empire State Buildings and deformed reindeer, and
there was a fantasy football trophy.
There was I didn't see that one. I wasn't. Yeah. And then and I'm sorry we don't have it, but we there are these sort of XLR connectors. Oh, I should put it. So there's a company in Berlin called. This is better than.
We're not good with the table device stuff.
Yeah, it's not like we're sound people. Kortwich is a company in Berlin that makes these amazing sort of right-angle connectors, but there were two issues that we had with them. One is that they're in Germany, which is good for them and not so good for us to import. and two was that you couldn't service them easily because of the way that people did it, and they did it was epoxy the end cap. So, these were two problems that we wanted to solve. So, I was able to sort of figure out a kind of idea for them. If we sort of took off the boot and then drilled a hole, well, that sort of could accommodate a cap. And then we have our electronics technician, Alexander, who said, well, if you really want to make it serviceable, you should make it so you can twist it off with a coin, and that's where the slot came in. But yeah, the threads were tricky, and there's a program also free called Openscad, Open-S-C-A-D. And basically it's like a programming version of Tinkercad. So instead of a graphical interface, it's all text. And somebody came up with a program to make threads. You sort of had to type in the pitch, and you had to type in the thread count and the diameter, and it came up with a shape. I wonder if we have, is this my account or?
It's mine.
All right. Anyways, it came up with the raw shape, and it wasn't until I figured out that you could make the shape of threads a whole into a solid cylinder. So, Jared, if you click on the screen, I'll sort of, yeah, I mean, it was, that's a little, wasn't that big, but
Yeah, that's
it, yeah. That the threads became a whole. Now, by the way, threads are a part of Tinkercad. If you go into, I think,
It's
user,
true.
yeah, if you go into user community,
Mhm.
yeah, or one of these, yeah, that's one of these.
Somebody's made a ton of different threading options
Yeah.
that you
and
can change.
So you can make your own end caps. And the whole upside down thing came about because I'll bring this back to the close-up camera, Jared. I'll get my hand out of the way. There we go. Yeah, it's got, let's try a green one, it'll be a little bit more visible. It's got a little bump. Also, that was Alexander's idea. The idea is that it gently pushes the solder points of the Xlr connector down a little bit. But it was tricky to print that way, so I ended up printing it upside down. And again, like the G and the S that you see here, those were the letters. There are actual letters that you can print with in Tinkercad. And I just turned them into holes into the cylinder. So yeah. I would, I encourage anybody to start to mess around with Tinkercad, and I really encourage people to keep it all open. That the idea behind this is that if you have some kind of problem that you need solving, it's likely that your fellow sound mixers do as well. None of us are really going to get rich off this stuff, so why not share it? And also, no one person is going to have all the ideas, so when you share it, other people can modify it. Here's an example we built with Arduino, which is, I suppose, a whole other topic. Something that allows Metacorder to be triggered by a 788T. So you press record on the 788T, GPIO contact closure goes into an Arduino, little tiny Arduino board, and it appears as a MIDI device, which then triggers Metacorder. And it was perfect, except we didn't have a case small enough that we could hide away in a sound card. So Natalie designed a case that just sort of snapped over the Arduino board. It was an Arduino, a Teensy was the board that we used. Yeah, and the logo, again, the logo was solid, and you just made it a hole into the shape of the case, right?
Yeah, onto the lid, actually.
Yeah, and sort of sunk it down.
But yeah, this ended up being a puzzle box that when you rotate it all the way and lift it up, you could put the two pieces together. Oh, I guess I'm missing. I've not grouped those two little guys, but
Right.
this was the whole idea, and it came out. It came out beautifully, actually.
Yeah.
It's working very hard on somebody's sound cart right now.
Danny Michael, a
Aha.
toolless enclosure case.
Yep.
Yeah, there you go. So yeah, I hope we've inspired people. I'm going to look for comments. I don't see any comments.
They're all on Tinkercad right now.
I hope so.
Trying to figure it out.
Well, so we're really trying to stick to a weekly event schedule. We are completely open to your ideas for podcasts and videocasts. I hope this one has been inspirational. I know I've been inspired. Have you been inspired?
I have been inspired.
I'm inspired.
And everybody else in the room has been inspired too. So I guess this is where we wrap it up.
Yes, thank you very much for joining us. I'm Natalie Lowe. I'm on the sales team. If I haven't responded to your email in the last 20 minutes, thank you for watching, and I'll be right with you. But please, if you have any pre-order questions, you have any questions as we go along in the next year about what's coming out and what's possible, feel free to always call Gotham Sound or send us an email. We are here and we are interested.
Thanks for watching.